How many four-digit numbers have all three of the following properties? First property is that the tens and ones digit are both 9. Second property is that the number is one less than a perfect square. Thirdly, the number is the product of exactly two prime numbers. So we want this number, which I'll denote by n, has to be of this form, where we have two digits followed by 9. And this has to equal some perfect square minus 1. So I'll denote k to be the number squared. So if we add 1 to both sides of this equation, any number that ends in 9, if we add 1 to it, we're going to get a number that ends in 0. So as a consequence of this, this means that k squared has to be divisible by 100. Equivalently, k has to be divisible by 10. Okay, so we now know that n has to be 1 less than a perfect square, and that perfect square must be a multiple of 100. Next, we can use the fact that k squared minus 1, this actually factors using difference of squares. This is equal to k minus 1 times k plus 1. And so in order to satisfy property 3, it turns out that both k minus 1 and k plus 1, these both have to be prime. So therefore, we can find the number of possible values for k such that k is divisible by 10, and k minus 1 and k plus 1 are both prime. Now, we also have some additional conditions on k. The first condition is that k has to be at least 40. And so why is this? Because if k was 30, that's the next smallest multiple of 10. If k was 30, then k squared minus 1 would be 899, and that's not a four-digit number. So the smallest possible value that k can be would be 40. Now, the largest possible value to consider is not 90, but 100, because 100 squared minus 1 is the number 9999, which is a four-digit number. So we just need to test how many values of k are there such that 40 is less than or equal to k, less than or equal to 100. K is divisible by 10. And lastly, k minus 1 and k plus 1 are both prime. So we can go through each of the choices from 40, 50, 60 up to 100. And it turns out the only possible value for k is going to be k equals 60, because 59 and 61 are both prime. None of the other candidate choices for k work. In particular, k equals 90 does not work. This is a pretty easy one to mess up, because while 89 is prime, 91 is not. So 91 is 7 times 13. So we can now conclude that there's only one possible value of k, which is 60. This is going to lead to the following value of n. 60 squared minus 1, which is 3599. And this is the only possible value. We can say that the answer is going to be B1.